Welcome back, folks. Today in lesson 3.2 we're talking about the chain rule. Okay, big lesson today. The chain rule is going to be something that applies across a lot of different situations as we move through the rest of the year, really. Okay, something that's very generalizable. Okay, and something we're going to need to continue to build our understanding of calculus. Okay, so objective to find derivatives using the chain rule. Here we go. All right, so the chain rule applies to composite functions. So before we get into actually looking at the chain rule, let's just remind you what we know about composite functions or function composition from Algebra 2 and Pre-Calc. I'm going to say a function is composite if you can write it as f of g of x, okay, where I have two functions, f and g, and notice g of x is actually within the f function. We'll call in this case g the inner function and f the outer function. All right, so with that in mind, first thing we're looking at doing is just identifying composite functions. Okay, which of these represent a composite function? And then for the composite function, identify the inner and the outer functions. All right, so first one, y equals x to the third plus 5x. Okay, we have two separate functions here, x to the third and the 5x. But I don't have one within the other one. Okay, you could think of this as just f of x for the x to the third plus g of x. Okay, that's not composition. And as far as taking derivatives go, we already know how to deal with adding two functions together. So here we just say no, it's not composite. Whereas down below, I've got the same two functions, x to the third plus 5x raised to the fourth power. This one is going to be composite because we have kind of an inner function, this x to the third plus 5x. We can say g of x is equal to the x to the third plus 5x. Okay, all raised to the fourth power, meaning that my outer function, we can call it f of x, is just going to be x to the fourth. Okay, if I took this inner function, x to the third plus 5x, and raised it to the fourth power, I'd have this resulting y equals equation here. Again, that's an example of composite function. Moving on up top, for this one, x times sine of x, I'm going to say no again. Okay, this is two functions just being multiplied together. We already know how to deal with the derivatives of functions multiplied together. That's our product rule. Okay, so in other words, not composite. Whereas down below, this g of x, here we do have a composite function. Because here I've got my x squared within the parentheses of the sine function. So for my inner, I can just say x squared. And in this case, I'm not going to call it g of x because our function's already called g of x. Okay, so again, we'll give you the rule in terms of f and g, but we want to think more in terms of inner and outer as we go through. And then here my outer function is just the sine of x. Because if I place the x squared within that sine of x, I'd get this g of x we see here. All right, a couple more. H is going to be a yes. Okay, what I have here is e to the, instead of x, the 3x. So simple inner function, just the 3x. And if I place that in the outer function, if I compose it with the outer function, e to the x, I'd get this e to the 3x here. All right, the bottom here for k, I must call this a no once again. I do have the same two functions, 3x and e to the x from above, but here I'm not composing them. I'm not putting one within the other. I've just got a product of two functions once again. All right, so now that we're good to go with composite functions, let's take a look at finding the derivative of composite functions. That's going to be our chain rule. So we'll say the derivative, d over dx, of a composite function, f of g of x, where f is the outer function, g is the inner function, is going to be the derivative of f of g of x times the derivative of g of x. Or in other words, the derivative of the outer function of the inner function times the derivative of the inner function. All right, we're not going to worry about proving that rule for you in this video. We're just going to dive into some problems where we find the derivative of composite functions using our chain rule. So let's get going with that. All right, so problem 2, for each function find dy over dx, okay, the derivative of y with respect to x for each function. So in other words, find y prime. And I've got our chain rule up top here, kind of color-coded to help us keep track of things. Part A, we're going to look at that first composite function from the last problem and actually find its derivative. And the first thing we're going to do is identify kind of what is my inner, what is my outer function. As we get going, we'll think in terms of f and g. Okay, we'll want to eventually move away from that just because maybe our function that we're finding the derivative of is called f of x. Or maybe we're going to mix it with the product and quotient rule, so there's multiple f's and g's in those definitions. But for now, let's just say that my outer function, f of x, is equal to what's on the outside here. That would be this x to the fourth. And then my inner function is everything we're raising to the fourth. We'll call that g of x for now, which is going to be the x to the third plus 5x. All right, now if this is my f, this is my g, we can take the derivatives right away. F prime of x is going to be equal to, using my power rule, 4x to the third. And then for g prime of x, we can just use that power rule twice, 3x squared plus derivative of 5x will just be a 5. All right, so here's my functions along with their derivatives. Let's go ahead and figure out what y prime is for this guy then. Okay, chain rule says find the derivative of the outer function, which is to be this 4x to the third. And I'm going to write that as 4 parenthesis to the third here. That's going to divide our work up a little bit, just so we don't run into each other. I'm going to leave the parentheses open because that's where my inner function is going to go. It's the derivative of the outer function with the inner function normal placed on the inside. So that'll just be my x to the third plus 5x. All right, then times the derivative of the inner function, which is my 3x squared plus 5. I'll put that in parentheses as well here, to make sure we get our distributing done right. All right, so there we go. That's the derivative actually here. Now, I could clean this up a little bit. If I want to find just what this derivative is evaluated at a specific x value, this is good to go. I can just start plugging those x's in. But as far as kind of coming up with an answer for a multiple choice test, I have a feeling that AP exam would distribute this 4 into both of these terms here. Now I can't distribute it into the x to the third piece, okay, because I have this third power here. So we could write that as y prime's equal to, we could say 4 times 3x squared would be a 12x squared. All right, plus 4 times 5 would be a 20. And then we'll just leave it as x to the third plus 5x all to the third power. That's about as simple as we're going to try to make it. If we want to take this any further, what we'd actually have to do, and definitely don't do this, is we'd have to take 12x squared plus 20 times x to the third plus 5x times that 2 more times x to the third plus 5x times x to the third plus 5x, and then go ahead and FOIL all this over and over again. No thanks. Okay, which is why we'll leave that kind of in a more functional form right here. Let's take a look at another example. And for this part of the lesson, I'm going to run through 4 different examples just to show you some different ways things can work out. I'll give you a chance to try 4 as well. Okay, so again, we want to find the derivative of y equals sine squared of x. Now, just like when we're applying our other derivative rules, might not be a bad idea to rewrite this in terms of something that looks a little nicer to apply the power rule to, because here we have something squared. So I'm going to rewrite this as the sine of x all squared, just to kind of show that that squared is on the outside. You could, in addition to that, throw an extra set of parentheses around here, okay, which might be a little overkill. But either way, we want to show that I'm taking the square, okay, of the entire sine function there. All right. Once we have that rewritten, then we can start thinking about what's our outer and what's our inner function. Okay, outer, once again, we'll call it the f of x, is going to be what we're doing on the outside of the parentheses, squaring. So we'll just call that x squared. And our inner, on the inside here, the g of x, is the sine of x. Okay, we can find the derivative of both those. F prime of x, using the power rule, will just be 2x. And g prime of x, derivative of our sine function, is just cosine x. All right, so let's go ahead and start figuring out what y prime is. We want the derivative of the outer function first. Okay, derivative of the f. That's going to be our 2x. And again, I'm going to write that as 2 with parentheses instead of the x, because I'm going to fill into that my normal g of x, which is my sine x. All right, then times the derivative of the inner function, the g of x, which is my cosine x. And I'm going to say that's really it. As far as cleaning this up goes, I can just lose my parentheses, which aren't really doing anything. I can just call this a 2 sine x cosine x. And we can have parentheses around the x or not have them. Either way works. But yep, this is all the further I can simplify that down to. Okay, there's my derivative function. All right, another example for you. We've got y equals square root of 3x squared minus x. Okay, I think with the square root one, it's pretty easy to tell what's on the inside. That's just what's in the square root, and then the square root's the outer part. Now, just like we did in the last problem, and just like we've done anytime we've taken the derivative of a square root, let's rewrite that in terms of something I can apply the power rule to. So I'm going to rewrite this as parenthesis 3x squared minus x, all raised to the 1/2 power here. All right, and then let's just dive into our derivative. I'm not going to bother writing the f, g, f prime, g prime out, just because as we get into more complicated problems, we want to just kind of take this a step at a time here. Okay, so first thing we're going to need is the derivative of something to the 1/2 power. So the derivative of our outer function. We'll just color code that in blue here. Well, that's going to be using my power rule, multiplying by the power, 1/2. Okay, and then times, if I take 1 away from that power of 1/2, I'd get a negative 1/2. So we'll go to the negative 1/2 power. And we'll put in those parentheses everything on the inside, my inner function, my g of x, just the 3x squared minus x. All right, so there's my derivative of the outer with the inner function plugged into it. Next, we need just the derivative of the inner function. Okay, so the derivative of this 3x squared minus x. I'm going to throw that in parentheses. Derivative of 3x squared is just going to be 3 times 2 is 6, x to the first power. Okay, and then minus derivative of an x is just a 1. All right, so there we go, chain rule complete. There's our derivative. Now there's a few things we could do to clean this up. We can say y prime's equal to, I can turn this all into one fraction. I've got the 1/2, so we'll throw a 1 on top for now, 2 on bottom. This 3x squared minus x, all raised to the negative 1/2 power. We could turn that into a 3x squared minus x to the positive 1/2 power on the bottom part of the fraction. And then we'd have this 6x minus 1 up top. And I suppose I can clean that up by just getting rid of this 1 here. Parentheses aren't doing me anything. So we can just say 6x minus 1 over 2. And then here, let's flip this back to a root. AP exam, answer might be left as far as your A, B, C, D choices in terms of a 1/2 power. Or it might flip back to a square root. All right, either way, we'll say one of these two would be what that answer is going to look like. We'll go with this guy here. All right, let's go ahead and rock through one more of our, we'll say, basic chain rule questions before we give you a chance to try some of these on your own. Okay, we want to find dy over dx of y equals the natural log of sine x. Okay, we've got the natural log as our outer function, sine x is our inner function. Pretty straightforward here. So when I get into finding y prime, that's going to be equal to the derivative of the outer. Okay, again, my outer is just my natural log of x. I know derivative of natural log is just 1 over x. So I'm going to say 1 over a set of parentheses here. Probably don't need the parentheses, but not a bad habit to be in. Okay, so the derivative of the outer function with the inner function plugged into it. So in place of that x here, we'll put that inner function, that sine of x. All right, and then just times at the end the derivative of the inner function. In this case, that's my sine of x. I know derivative of sine x is just cosine x. And we can clean that up by thinking of this as cosine over 1. So here we're just multiplying fractions. Cosine x on top. We've got the sine x on bottom. And I suppose I can simplify that down to, I know that cosine over sine is cotangent. So this derivative does simplify down to just a cotangent of x. All right, so there you go. Tried to give you a good mix of different ways the chain rule can work out, along with how it applies to the different functions that we already know how to find the derivative of. Okay, there's 4 more problems in this part of the note guide. Why don't you take a few minutes, pause the video, see if you can work through those, and then hit play to check your answer for those next 4 here. All right, so I'm going to cut this lesson off here. Okay, we'll say we're through the first half of it. So why don't you take some time and try to work through the first half of the homework? Okay, get some practice with the basics before we get into some more of the advanced extended chain rules in the rest of the lesson. Okay, so give that a shot, and we'll be here to help you out if you need it.